Hello and welcome to this online course on machine learning with Python. In this tutorial, we'll be exploring how to use PyTorch, a powerful deep learning framework, to create and train a neural network on a classification task. In this, specifically, we'll be using scikit-learn to generate synthetic data and to split data to train and test data sets, and then train a simple feed-forward neural network to classify the data. First, we need to import some libraries such as scikit-learn, PyTorch to work with the data set and create neural network. Here, we are actually generating the data set by using make classification from scikit-learn, and the number of samples we have is 10,000 and number of features is 4. We also mentioned the number of classes as 5. So once we have trained data set, we'll split it into train and testing data using train test split, where we are mentioning actually test size as 0.33, but it depends on actually you how to define the test size. As a rule of thumb, default it's 0.2, which is actually 20% of the data. So 20% is a test size and 80 is train size. In our case, it's 0.33. It's actually up to you, and random state actually lets you to generate the data set, and whenever you are randomizing the results, you will always get the same results. So random state makes sure that you are utilizing it right way. So now we are ready to create a PyTorch data set that we can use to train our neural network. We create a data class by inheriting data set from PyTorch. In the constructor section, we actually convert numpys into PyTorch tensors and set the lengths of the data set. This actually for the in order to avoid some runtime errors, we need to make sure that we are using the right type, such as float32 or long tensor for y. And there is also lengths, which is for actually lengths of the data. There is we are also defining the get item function, which is for getting the data set based on the index, such as from x and y. And the lengths actually lets us to get the lengths of the data. Once we create the trained data, we actually need to make sure that like batch size is 4, because based on that we are actually getting some generated version of the data loader that is letting us to get the trained data based on the batch sizes. Shuffle through makes sure that you are shuffling the data in a correct way. And as we have the 4 features, we need to make sure that like input dimension is 4. Hidden layers is 25. This is actually up to you, but that's supposed to be right up with the number of the data that you have. And there's also output dimension, which is for the classification purposes. Since we have 5 classes, we'll mention the output dimension as a 5. So later we then create an instance of neural network, define the loss function and optimizer. Here you can see we are actually getting the neural network class. We are actually inheriting some with the help of the super. We are inheriting from the network. We are creating the linear 1 and 2, which is for the 2 sides of the hidden layers. There's also forward function, which is using sigmoid function. That's actually a simpler version of it. Later on, we are ready to train our neural network. We use a loop to iterate over the data in the data loader, perform and forward and backward pass. We set the optimizer gradients here. Later on, we are also making sure that like we do have the criterion, the right way of the criterion for the loss function. There's also optimizer, which is SGD, that stands for stochastic gradient descent. We are also training it in 2 epochs and trying to get the final result. This is actually a print function, which is letting you to see the loss function per each epoch. Since we have 2 epochs, our loss will be 104 and 0.85, And after training the model, we can actually easily save it. All you need is just to make sure that you have the right path, and then you can actually easily save the torch to given path. Then that lets you actually to use neural network in the past. In conclusion, neural networks are a powerful and exciting tool for solving complex problems in a wide range of industries. If you are interested in learning more about that, there are plenty of resources. You can actually use our courses. Thank you for listening, and I hope you have a great day.